In this lab, we're going to use the Desmos online graphing calculator tool to analyze two-dimensional motion that we have obtained from an in-class video. In this case, it is a cart moving down an inclined plane, which means that we have motion in two dimensions, both the x and the y. So first things first, let's open up desmos.com and open up the graphing calculator, and let's start a new table. So we can click on the plus button, click on table, and we can assign it some values. Flipping over to my video, I just have it in ChipChamp for now, but you can use any editor to get this timestamp footage. We're going to sort of look at the horizontal movement first and the gradations. So we have 0 here. We have to remember in class it was 0, and then each line was half a meter. So 0, 0.5, 1, 1.5. So we know that our distances are going to sort of be set, and they're going to be looking for the time at which the cart crosses these vertical lines. So knowing that, I'm going to go back into Desmos and into my y dimension, even though it's technically the movement in the x. We're going to put this as our position, and we're going to put those in right now. So I'll go ahead and do that, and I'll be right back. All right, I've put in the values 0 through 4, incrementing by half steps or half meters, and like I said, those are the vertical lines we've drawn on the board. And this is the confusing part, I guess, for some people, is because we're discussing horizontal movement, the cart moving left to right, and then using vertical lines up and down to sort of mark our sort of checkpoints. There can be some confusion that arises because we're using the words vertical and horizontal at the same time. So in this video, I'm going to do my best to use the terminology vertical line as the actual line on the board, and then our horizontal movement is left to right. So what we're going to do now that we know that we have the timestamps, we're going to scrub and move our video all the way back to the start, and we're pretty much looking for the times that we cross these lines. So I'm going to go and hit play, and I'm going to try to pause it right when it crosses the line. I didn't quite get it, so I'm going to take my video slider and move it back a little bit. If you're doing this on a phone, you can do it just by sort of hovering over the editing footage and moving back and forth, and your finger should show the timestamp. So I'm just about to cross the 0.5 line at, and I can come down here and hover on the slider, at 0.0 seconds or 0.75 milliseconds. So we'll take that milliseconds and we'll put that in. So we'll come up here and we'll go to X and we'll go 0.75. Okay, so we have that. And we're going to hit play. Oh, and I missed it. And you're just going to go through and sort of capture each one of these lines right when it's about to cross. You can either use the front edge of the cart, the middle of the cart, or the back end of the cart. As long as you're consistent as you cross each vertical line, you will capture accurate horizontal movement. So at this one here, for example, if I hover on my slider, I'm at 1.09. And I think I misspoke earlier and said milliseconds, but we have 1.09 seconds there. So you're going to go ahead and fill out all the timestamps for these data points, and I'll do that right now, and I'll be right back with you. All right, I'm back with you. I realized I made a mistake when I put in the timestamp for hitting the half meter mark. I put it in the wrong location, so I just moved all my values down. But what you can see now is this chart produces a quadratic curve. You can definitely see it's curving, it's not a line. And we can see that as we go up, it seems that our time in between consecutive data values is increasing slightly for each known increment of half a meter. So we'll go ahead and keep that as our position data for the horizontal, which is y1 in this plot, and x1, which is our time. One thing to note, going back to the ChipChamp, there was a couple times where the cart, I couldn't quite get it to line up with the line because it was sort of in between frames. So rather than sort of going and saying, in this case, this was 2.3 and a frame back was 2.29, instead of rounding it to 2.295, I just chose to round up to the nearest whole number. So I had to do it here, and I think there was a frame over here somewhere where it didn't quite line up. So as long as you're consistent as you go, the data should work itself out in this experiment. Now we're going to have to repeat this. We're going to come all the way back with our footage, and this time we're looking for the times where it crosses the horizontal lines. The horizontal lines are going to be used to track the vertical movement as the cart goes from up here to down here. So we have to think of this like our rise in terms of slope, so rise over run. these vertical lines, or sorry, horizontal lines are going to help us track the vertical movement as the cart drops. So I'm going to go ahead and do that and do the same thing. We're going to go into Desmos. We can just come up here on the top and type in Y2. This will be our vertical movement, and we will go through and fill in the timestamps as needed. Looking at this, it's not going to work amazingly well because we actually don't have the increments that we need. So maybe what I'll do is actually make a new chart. So I'll go plus table, and we'll make a new chart. This time we know that the increments go up by 0.2 of a meter. So 0, 0.2, 0.4, and just go all the way up to 1 meter. And again, we're going to go find the timestamps and make another graph. So I'll go ahead and do that, and I'll be right back with you. So I went through and I put the time values in. I made the same mistake like I did before, worrying about sort of pausing the video. So I moved my 0.89 down, and we got our data points. This 2.42 is just a quick estimate. I'll bring up my video editor just to show you. We do have these little ticks on the side of the board, which we use to draw the chalk lines. We can see that's just above it. So I'm going to assume that it is touching that line. And we're just going to go from there. A little bit of inaccuracy at that last data point shouldn't make a huge difference today. So we have 5 data points, and as we can see, we now have 2 charts or 2 tables. We have x1, y1. This is our horizontal movement. And then we have x2, y2, which is our vertical movement. And we can see that we have 2 curves. So that's it for getting the data off of the video and bringing it into Desmos. I would suggest saving this by maybe signing up for an account or saving the data somewhere into an Excel table or Word document so they can use it again in future labs. And join me in the next video when we look at how to apply regressions to these curves and get our A, B, and C constants so that we can use that to generate a velocity time graph. Thanks for joining.